Okay, Physics H. How to attack these projectile motion questions. So, I'll take a look at number 10 here kind of quickly. You guys are going to be doing it, and we're gonna go through it in class. But it says a diver jumps off a 10-meter platform horizontally with a speed of 2 meters per second. So, 10-meter platform is actually pretty darn high. But anyhow, all right. So diver jumps off horizontally. So whatever move they're doing, they leave horizontally. It's a 10-meter high platform, and they leave horizontally with a speed of 2 meters per second. All right. So their initial velocity, they jump out horizontally. Now they jump out, and gravity starts to pull them down, right? Like as they move, force of gravity is pulling them down. They get faster in the vertical direction, but there stays a constant speed in the horizontal direction. So with all of these, you always just remember that AX is 0 meters per second, and AY is negative 9.8 meters per second squared. That should have been meters per second squared. All right, so always remember that. Now, the way I like to go about this is to set up two organizational tables. Now, we don't need to do the full organizational table in the x direction, right? Because Vx, we're just going to call it Vx. That's 2 meters per second. That's the same speed the whole time. So it's the initial speed, the final speed, the average speed. It's all the same, 2 meters per second. Delta x is what we're going to be looking for here, how far from the edge of the cliff they land, or the platform they land, or the pool edge, whatever you want to say it, and then the time. All right, so we don't know either of those yet. Now I am going to make the full table for the y direction. Now I will say in the y direction, v initial y, v final y, v average y, acceleration y, delta y, and t. Alright, so I'm using y, delta y, for the vertical displacement so we can keep track of it. Now the coordinate system matters. His initial position I'm saying is 0, right? And I'm saying down is negative. To the right is positive. So it's just like a normal coordinate system that we would usually use. So when you throw something horizontally, right, its initial y velocity is 0 meters per second. Now here's a warning to you. The final velocity is not 0. The final velocity is the speed, the vertical speed that this object has, the instant before it hits the ground. All right, the instant before, so it's not 0. Average, I don't know. AY is negative 9.8 meters per second squared. Delta y is however far down this object's going to fall, right? So it's going to fall down 10 meters. So delta y, you want to put in a negative 10 there for the vertical displacement, negative 10 meters. The time, we also don't know. So it doesn't look like we know very much here, right? However, if you look at your equation sheet, we really pretty much end up using two equations here, always. Pretty much the same two equations always when we're solving these problems. We're going to use, for this one, we're going to use, delta x equals average velocity times time, which I guess starts out as average velocity equals delta x over t. Multiply both sides by t. You end up in this form of it. And average velocity in this case, since, remember what I said earlier, the x velocity never changes, so the average velocity is just 2 meters per second. So I'm going to be able to get delta x once I get the time. Now the time here, all right, the time I'm going to get from the y direction. So in the y direction, we pretty much always use El Grande, delta y equals 1/2 AY t squared plus v initial y times the time of flight. And the reason we like to use this one is because, well, we're looking for time. We know delta y, we know ay, we know v initial y. And since v initial y is 0, this whole term disappears. Right? And this whole term just goes to naught, goes to 0. So now we have delta y, we know that, right? We know ay and we know t squared. Now delta y is negative 10 meters. Ay is negative 9.8 meters per second squared. The signs are very important here. If you make this negative, then you also have to make delta y negative. If you want to say down is positive, you can do that. You can make down positive and just call these both positive. Whatever direction the object is going in, that's its delta y. Whatever direction it's accelerating in, that's its ay. So I said down was negative here, so those are both negative. If you make them both positive, it doesn't actually matter because the negatives are going to cancel here when we do the algebra. So we got to solve for t. Well, I'm going to multiply both sides by 2. Right? I'm going to divide both sides by negative 9.8 meters per second squared. Alright, so I get t squared equals 2 times negative 10 meters divided by negative 9.8 meters per second squared. This is a case where it's actually nicer to use negative 10, right, for g, because that would have canceled. But I'm going to stick with this calculation like this. Let me just quick spot a calculator here and grab it. Be right back. All right. Got the calculator here. Sorry about that. Rather than pausing it, sometimes that's a pain. So 2 times negative 10 divided by negative 9.8. And again, the 10 is going to cancel. And look, you get t squared equals 2.0. See, to 2 sig figs, you end up with 2.0 anyways. So radical 2 is 1.4. So the time to fall 10 meters is 1.4 seconds. So if it takes 1.4 seconds to fall down 10 meters, the object's gonna move forward while falling. Delta x equals 2 meters per second moving forward for 1.4 seconds. And you're going to get a delta x of 2.8 meters. The seconds cancel. Over here, if you're not sure what cancels, the meters cancel and the seconds go upstairs. So you actually have 2 seconds squared. And then you take the square root of both sides. Right? So the units end up getting the square root of them as well. So 2.8 meters. All right, so that's A and B on number 10. Number 11, now you got to be careful with number 11. Another diver jumps off the same 10 meter platform and hits the water 1.5 meters from the edge. With what horizontal speed did the diver leave the platform? So for this one, for 11, you know delta x is going to be 1.5 rather than 2.8. All right. So you know delta x is 1.5. You know the time of flight is still going to be 1.4, so you don't need to redo everything. The time of flight is still 1.4 because it's still the 10 meter platform. That's the point of this question. All right. The fact that the platform height does not change, that means the time it takes for this diver to hit the ground also does not change. All right. So see what you can do with that. Now, I do want to talk a little bit about one like number 12. I'm not going to exactly do that one, but I'll show you. If you got a plane or a car or something, you know, let's just make it a plane like the problem. Gotta get some more Sharpies here. I saw some headline that said the F-35 is officially a failed plane, which is news to me, but that's interesting. Let's say we're on some aid mission, and we're gonna drop this crate of supplies, right? Well, if you ever played a video game that involves airplanes or whatever, and dropping a bomb or something like that, you always have to aim ahead of where you want the object to land, because if you release this when you're right over top of whatever you want to drop it on, right? If you release it then, well, you got to realize it's not going to fall straight down, because it has whatever the initial velocity of the plane is, right? The thing below it has the same initial velocity, right? So this thing's actually going to fall like this and land over here somewhere, right? So if you want the object to hit the target, you got to drop it back over here somewhere, so it'll move forward while it's falling, all right? So in this case, we know how high off the ground, we know the speed, we're going to have to find the distance. Now, I want to change things a little bit here. Let's say, this plane, right, has to travel at a certain speed. Let's say it has to travel at 85 meters per second to stay in the air, right? Say it has to travel at least 85 meters per second to stay in the air. All right. Let's say there's some sort of obstacle, right? Let's say there's some sort of obstacle. I'm trying to think what this might be. Let's see. Let's say we want it to, let's say there's like a mountain or something here, and it's got to fly up. So it's got to drop it at least 100 meters before it gets over the drop zone, right? Let's say this is at the base of a mountain or something, right? And it's got to drop it ahead of time so that it can turn and evade the mountain, all right? So how high above the ground should it release the package is what we want to figure out, all right? Now, the reason I want to do this one like this is because we're going to have to start in the x direction here. So we do the same procedure, Vx, delta x, and t. I set up the same V initial y, V final y, V average y, acceleration y, delta y, and t. I set up the same two graphs here. Oops, my paper's shifting up out of the frame. Sorry about that. So the plane's going to turn up and evade the mountain. So we got to release it 100 meters in advance to be able to make that turn. So how high off the ground should the plane be? That's what we're looking for here. So I know Vx, it's got to be traveling 85 meters per second. That's as slow as it can go. We want it as slow as possible so the crate doesn't just get obliterated. Delta x here is 100 meters. We want it to go 100 meters forward while falling. V initial y is going to be 0. We're just going to release it. Acceleration y is going to be negative 9.8 meters per second squared. Delta y is what we're going to be looking for. So in this case, we're not going to start with the y direction like we did in these other problems. We're going to start with the x direction because look, we have two of the variables here. So delta x equals vxt. We're going to solve for t using the x direction. All right, t equals 100 meters divided by 85 meters per second. 100 divided by 85, it's 1 point something, right? It's 1.2. It's going to take 1.2 seconds for this crate to hit the ground. Well, I shouldn't say this. We need it to take 1.2 seconds for this crate to fall down. So the plane here, the crate's going to have to move forward 1.2 for a length of time, 1.2 seconds, in order to move 100 meters, right? So then over here now, we can take that time, 1.2 seconds, and we go to El Grande, delta y equals 1/2 ayt squared plus v naught yt. Delta y, that's our altitude we want the plane to fly at, so we can just plug everything in here. I'm not going to put units in this time, just to keep things simple, this term again goes to 0, right? So it's just plus 0. Don't forget to square that. Very common mistake. And now look, we don't even have to rearrange anything. We can just go right to the calculator. Times 9.8 times 1.2 squared. 7 meters. That's crazy. 7.1 meters off the ground. So this plane's going to have to be real low. It's going to release it. The crate's going to go flying forward, and then it's going to turn up and take off up towards the air. All right. So this is a problem when you make a problem up on the fly. I probably should have made that speed a little slower, you know, and have to be a little higher, but oh well. So it's going to have to get real low. 185 meters per second is almost like 170 miles per hour, which is actually pretty slow for a plane, but it's fast overall, I suppose. The point here is that, you know, I give you two things to start off with. You always know AX is 0, AY is negative 9.8, and then it's just a matter of figuring out whether or not you start in the X direction or you start in the Y direction. And that's going to be dictated by the initial quantities that you're given. So that's how you pretty much go through and do all these. Let me just look at the packet quick. Did I give you the review sheet already? Yeah, so projectile motion practice. We're not going to get very much into 13, 14, and 15. Those are a little trickier. But we will take a look at the review practices, which are very good. These are good questions. This should help you with that. All right, have a good one.